And welcome Geometry to Chapter 9, Section 5, Symmetry. And come back after having tried these warm-up problems and check your answers. Rotation for number 1. Number 2 is a reflection. Our 180 degree is simply opposite in the x and y coordinates, right? And the more interesting rotation is our 90 degree rotation, which gives us opposite y, x in the coordinates. Today we're going to identify and describe symmetry in geometric figures. So here is the vocab, the important vocab: symmetry, line of symmetry, and rotational symmetry. So we know that a figure has symmetry if there is a transformation of the figure such that the image coincides with the pre-image, right? So a figure has line symmetry, also called reflection symmetry, if it can be reflected across a line so that the image coincides with the pre-image. So it looks like the left side of this heart reflects across this line of symmetry and lands right on top of the right side of the heart, or vice versa, right? The line of symmetry is also called the axis of symmetry, and it divides the figure into two congruent halves. So tell whether each figure has line symmetry. If so, copy the shape and draw all lines of symmetry. So for figure A, it's easy to see at least one of the lines of symmetry. It probably pops out at you, and maybe as you look deeper into this figure, you can see more than one. So we have two lines of symmetry, right? We have a horizontal line and a vertical line. Good. And for figure B, do you see a line of symmetry? And yes, we have one that is a horizontal line right through the middle of that letter B. Notice we could fold the figure on this line of symmetry, and each point on the top would have a corresponding point mirrored on the bottom, right? And this is a little tricky. Do you see a line of symmetry? Here, feels like if there was one, it would be horizontal, so you have to really check and see, would the stars really end up on one another? And yes, we do have a line of symmetry right through this vertex, straight across horizontally. Okay, so a figure has rotational symmetry, also known as radial symmetry, if it can be rotated about a point by an angle greater than 0 and less than 360 degrees, so that the image coincides with the pre-image. Rotational symmetry. The angle of rotational symmetry is the smallest angle through which a figure can be rotated to coincide with itself. The number of times the figure coincides with itself as it rotates through 360 degrees is called the order of the rotational symmetry. So notice with this square figure, we can rotate it 90 degrees, and we would end up having a square coinciding with itself, right? We could do that again, again, and again, and we would be back to the original orientation. So the order of the rotational symmetry is 4. We can rotate it 1, 2, 3, 4 times and end up back in the original position. The angle of the rotation in this symmetry is 90 degrees. So in this example, tell whether each figure has rotational symmetry. If so, give the angle of rotational symmetry and the order of the symmetry. So we look at figure A and we think about rotating it. Does it have rotational symmetry? No, it doesn't. We would have to literally rotate it, I guess, 360 degrees, and then it would land upon itself, which is not rotational symmetry. How about figure B? Can we rotate it in a number of degrees less than 360 and have it land on its pre-image? And yes, we can. We can rotate it 180 degrees and then another 180 back to the original position. So we have an order of 2. And in figure C, what do you think? And it looks as though this does have rotational symmetry, doesn't it? And it's a 90-degree angle of rotational symmetry, so it has an order of 4. Very good. Okay, so pause the video and check out these examples. Describe whether they have rotational symmetry. If so, give the angle of symmetry in the order. Come back and check your work. So A is a 120-degree angle of rotation, which gives us an order of 3. B is 180, order 2. And C, no rotational symmetry. Describe the symmetry of the icon and draw any lines of symmetry. If there is rotational symmetry, give the angle and order. So we do see a line of symmetry, and let's see if that's, I'm sorry, we don't see a line of symmetry. Actually, if we draw a line, we can't fold it upon itself, can we? And find corresponding points. But we do have rotational symmetry if we kind of ignore the black and white, right? So if we rotate this 180 degrees, we would have an image that looks as though we have points falling on their original positions, just reversing the color. So we could say we have 180-degree angle of rotation and an order of 2. Let's try it again. Let's first look for any lines of symmetry. And do you see any lines of symmetry in this figure? Let's see, if we draw a horizontal line, it looks like we could fold it onto corresponding points, right? How about vertical? Looks like it could happen again. What about diagonal? So yes, it does. So we have many lines of symmetry here. We also have rotational symmetry, don't we? And how many degrees would you say is that angle of symmetry? And yes, 90 degrees, which gives us the order of 4 once again. So three-dimensional figures can have symmetry. We call this sort of symmetry plane symmetry. If a plane can divide the figure into 2 congruent reflected halves. So this rectangular prism has been divided into 2 congruent reflected halves by this plane. This is an example of plane symmetry. So a three-dimensional figure could also have a symmetry about an axis. An axis is a line, right? If there is a line about which the figure could be rotated by an angle between 0 degrees and 360 degrees, so that the image coincides with the pre-image. So a cylinder, a perfect cylinder, has a symmetry about an axis, doesn't it? Tell whether the figure has plane symmetry, symmetry about an axis, or neither. In this example 4, we have a pyramid, right? A rectangular pyramid, or possibly a square pyramid. Remember, we name pyramids by the shape of their base, right? So do you think this has plane symmetry? Could we take a plane and slice it into 2 reflected halves? Or possibly axis symmetry? Maybe put a line straight down that vertex? Or neither? And it has both, doesn't it? And so we can see that we could take a plane and cut it right down the middle of the base, I guess, and the vertex, right? We could also do it in this other direction here. And we certainly could put a line straight through the vertex and straight through the center of that square, and we would have symmetry about an axis. Okay, in this example, tell whether the figure has plane symmetry, symmetry about an axis, or neither. And is there any way we could place a plane through the figure and have 2 reflected halves that are mirrored images? And yes, we could, right? We could cut it right kind of down the center and make 2 big L's, right? There it is. And is there a way we could place a line, an axis of symmetry around? No, don't think so. So plane symmetry is the type of symmetry we could have for this figure. So really, this is the focus today, and why don't you pause and come back and state what type of symmetry you have found in these 2 figures, and you can check your work. And in this figure we have both plane and symmetry about an axis, right? And this is an interesting figure, and we have, in this case, neither. There's no way to cut it, actually, to show plane or axis symmetry. And pause your video, come back and check your work. Okay, we have line and rotational symmetry in this figure. And we have an angle of rotation 90 degrees and an order of 4. There's no symmetry in number 2. Tell whether these figures have plane symmetry or symmetry about an axis or neither. And number 3, we have plane symmetry. Imagine a kind of horizontal plane, or I'm sorry, a vertical plane cutting right down the center of this. And this is interesting. It has a bit of a wavy base, right? So this has symmetry about an axis, actually. If you draw a line straight through the vertex and down through the center, we could have a 180-degree rotation. There you go. Have fun. Have a good day.